How's it going, everyone? Welcome, Emilier, again. Looking now at the escape hatch, this section from the Learn Docs of React, as a way to understand is how can we write React components in the most performant way. Part of this React Performance course, which is taught by Steve Kinney, head front-end engineer at Temporal, this open source durable execution platform, which is pretty much, you can think of this like some sort of Kubernetes to cover specific business use case. So for example, companies like Vercel actually make use of this. That's actually quite interesting. But the goal of this course is to look at how can we now write React components in the most performant way possible. And the goal of today's video is to now be able to understand this and describe this particular section as a way to understand now what the React is doing behind the scenes, the rendering. So we can move on to the next topic, and that is, well, what are the things that we can do? What are the tools, the techniques that we can do once we understand React, and then we develop a tool set that allows to identify this potential React bottleneck. But we need to first understand is how React works and be able to describe that entire process in the most concise and short way is one of the goals of this entire series of videos. And also is to, once we build this tool set to identify is this React performance issue, we can then later on come up with some best practice, some solutions to apply when we encounter them. So you can think of this pretty much like pulling the right, you have a big knot when you pick up the right threads, and then you pull it up and apply the techniques that you already learned over and over and over. And this is something that works for small apps to enterprise. Enterprise grade. So now, because this course is laid out in this fashion, so the introduction, React rendering, reducing rendering, context, and suspense. The point of today is look at how React rendering works, be able to describe that. Briefly describe is how can we now, or what is the value proposition of performance, not only in React but also in life. And that is, according to Steve Kinney, the rule of thumbs of the golden rules of Steve, right? Which is not doing stuff is way much faster than doing it. And there's some corollaries that you can get from that. So doing things later is much faster than doing today. So with that, now the whole point of this is to look at what are the things that you need to do, what is the priority that you need to do, and focus on that. And things that are not a priority, don't even think about it. So that's great, that's cool, because we also look at what will be is this some sort of tools that we later on going to take a look at that more in depth. But here is when you have any performance issue, whether it's a client or the PM, any college tells you that, you say, okay, in our case, let me now is look at the production, look at the build in production. Are they using is the production flag or dev flag? If not, so let me now take a look at the component hierarchy and the states, and let's go to start from there. Also, look at what is the memoizing strategy that this application follows, as well as how this application is now progressively load components, okay? And lastly but not least, if you're in a pickle, or if you're really in a pickle, use a transition API, which is now this concept of low priority re-rendering as a way to defer render, as a way to evaluate, as a way to let React evaluate stuff later on. So this is it so far with React 18. Good. Now, because of that, all right, the idea here is to be able to describe the learn sections as a way to make sense of how we get here, which is something important, especially as you develop and as you move on into the computer science career as a software engineer, as a web developer. So why is that? Because as humans, we make sense of the world through stories. And this is the reason why I'm actually looking at this. Now, after all, we're going to make a brief recap of all of this, okay? To actually hit what we care about this. First is React is a JavaScript framework that allows to describe UI. The way we can do that is through JavaScript functions. So we look at how can we import and export React components, aka JavaScript functions. Also, how can we use this markup syntax called JSX as a way to allow to put now HTML in JavaScript, to have them in one file and interact with that. How can we now interact with the JavaScript world with the HTML through the JSX curly braces, as well as now look at how can we pass down props to these components. How can we now rendering conditional components? How can we render lists of components? And how important when you're creating your components, aka your JavaScript functions, it needs to be in a pure way. Why? Because now these components allow you is to run in any JavaScript environment. So it gives you the flexibility, whether it's on the browser, the server, the worker. Also, you can catch these components, meaning that you can notify to React, hey, stop, do not compute, do not calculate, do not call this component. By using its memoizing strategy, like use memo. And also, when it comes to actually is compute, or when you passing down data and suddenly you want to stop the execution of that, you can do it in a safely way using pure functions. And then we look at how now React sees these components, looking at the render tree, which is a data structure that comes from the computer science. And the data structure is just a way of how can we organize data to satisfy specific use case. So for example, your backpack and your fridge is a way of how you can organize specific things to cover specific use case. So for example, in your fridge, you can put ice cream or fish, whether in your backpack, you can put is paper, keyboard, mouse, tablet, iPhone, you name it. If you swap the order, whatever you put in that, for example, you can put your MacBook in your fridge, which will preserve them for a long time. And anytime you get that, it's like, free, it's like cold. And you can put your fish in your backpack, okay? Anytime you open up, it's gonna smell like Detroit. Sorry, I'm sorry. It's like this is what I have. This is what I heard. Anyway, so the idea here is to, with this data structure, there are ways to organize our data to cover specific use cases. So you have array, you have stacks, you you have tags, you have lists, you have queues, you have trees, graph. So this is the way how now software engineers at Facebook decide to organize the way how you're going to interact with your React components, on how React see this component, and how you can think in that way. Why is that? Because now you can identify any performance issues when they happen, as well as how the data flow goes through each one of the components. Similar for the tree dependency, which is now used as the code that you're going to, reusable code that you're going to apply to these React components, and you want to prevent to send bloated code to your React components from the server to client. So there are several advanced techniques like tree shaking, like code splitting, as a way to prevent that. So now that we look at how can we describe the UI, then we take now a more practical, we get our hands dirty to the next topic, which is how can we now add interactivity to our components the React way. And that is, well, by listening to the event handlers in the HTML, okay, and then you write a function as a way to detect those changes and do something about it. But most of the time we want is to also show some data. For example, in your bank account or in your bank app, you want to look at how is your balance account, as well as the diagnostic history or transaction history, your credit cards, so on and so forth. So how can we now actually show some data here? So React come up with some solutions, which is a way of how can we now show data here and preserve that data, aka as a state. The memory is a components memory. So we look at how can we now remember things in our component, and when we need to update that, we do that inside of our functions event handlers. So with that, we set the state, and we're able to actually update the new value. So anytime we set the state, what happens is that React pass through this rendering mechanism, which is pretty much like an assembly line, right? It's made of 3 stages. So you got first a trigger that detects who made this, okay? Who poked me? And then it can be at the root render, or it can be at a component level, or any of its ancestors that update such state. So once React detects that, the next phase is, all right, let me now re-render this component, or in other words, let me now call this component. If this happened at the initial root, or the root element, remember we're talking about in a tree structure, okay? If that happened at the initial element, at the root element, at the tree, so React will gonna create those elements using the document of create element, okay? And we're gonna hold that information for the next stage. If it's not, if it's caused by a re-rendering, React will call that component that trigger that state updates. It's going to evaluate that. It's going to calculate its properties and props and states, that kind of thing, okay? And if the output, which is a JSX element, contains more React component, it will call that. And if that output contains more React components, it will call that, and it's gonna do that in a recursive way until there is no more React components in that tree. All right. So I think this is quite interesting and powerful to understand, because now if you remember that when React evaluate or call that component, the initial component, it also stores that data, okay? So for example, the store is the props, the states, it store that information for the next render, which is the commit phase. So this commit phase, what it's doing is now, if this happened at the initial or at the root element, because now React in the previous state create all of these elements, it is time to append those elements and show them to the DOM. It's using the append DOM API. However, if this was part of the re-render, what React is going to do is to apply the necessary DOM updates, okay? And yeah, it's going to apply the necessary DOM updates here, and as long as they're different between renders. So with that, okay, the whole point of that is that when React apply the necessary DOM updates or append those elements to the DOM, React or the browser, the epilogue section, what's happening next at the commit phase, the epilogue is that now the browser detects those DOM checks and paints that for you. So this is the mechanism that React goes anytime you set or you update an state. This is the foundation of what's coming next, because as you move on and look how you can create now more scalable components, it is interesting how all of this stack together as a way to make sense of now how you can build, for example, applications like Facebook or rich interactions applications. So now that we look at the mechanism, we also look at how can we think when we are updating our states, and that need to be done is on the event handlers, and what's happening inside of the event handlers when you're setting these states. So the state value change is in the next render. That's one. And the other is that you can think that React fix the state values within the event handlers rendering. So with this, we also look at how can we now, for uncommon use cases, queue a series of state updates, known as batching state updates. So that's great because with that, we can look at how can we, for example, define some async operation in your JavaScript functions and update or state or several of states using an arrow functions as a way to now get all of these states updated once that async operation happens. So this is also interesting, that particular case. I also look at how can we do that. This is indeed something, this is more like a curiosity. Because what is relevant is that how can we now update our state, or how can we now update objects and array in our states. The TLDR is that always return is a new object or a new array for that, regardless the state that you're using, or regardless the method that you use, always return is a new state from that, okay? And if you want to keep your state update consist, you can use IMER as a way to make it to look like or to use a mutable syntax. So now that we know how can we add interactivity to our components, it is time to now do the grow up work. Okay. So now we finally grow up. All right. We grow up here, and now we're ready is to actually look at how can we manage our states. As a way to look at how can we organize our state structures. How can we organize our state structure? How can we keep the state update logic consistent and maintainable most likely, as well as how can we now pass data to distinct components? If you remember, we do that with props. Why this is important? Because this is what allows to build all of this small user interface and scale that following the atomic design pattern, which is you start from the atoms and then from molecules. You start from atoms, then particles, then you start with atoms, then you start with atoms. You start with atoms, then with molecules, then with organisms, then with pages, and then with entire websites. So the idea here is that first we're going to look at how can we react input with states, react input with states. And this is by now the React mental model of describing its UI components. Before that, we have is in something that we most of the time do, that is the imperative approach. When you use this, for example, the query or the DOM as a way to interact with them, you tell exactly what you have to do. One of the trade-offs of this is that when you need to scale that or you want to create more complex things, as a way to adding more interactivity or to create more minimal stuff, or more meaningful stuff for the business, now it becomes quite hard to maintain. A good example of this is pretty much when you hit a taxi. I don't want to use any example here. Let's gonna move on. So the idea is that you have an imperative and a declarative way. So with this declarative way which is a concept that now was borrowed from the UI designers as a way to say, hey, because the UI designer create all of this wireframe, okay, to represent all of these different visual state, and when you combine that with a concept called finite state machines, now when you're going to create your components, React say, hey, this is the guidelines that we use as a way to build that. And that is identify all the different visual states, crucial, determine what trigger those state change, and that is it can be human or computer inputs. For example, typing, clicking, copying, or in the computer is receiving data from the server, loading an image, and then you represent those state using use state in memory. You eliminate any non-essential state, and then you connect the handlers to set the state. This is something that we look at when you're going to create this user interface patterns, okay? When you're going to describe this user interactivity or this UI and add interactivity to them. So when it comes now to, for example, look at UI selection patterns, you go with the index or an ID that must come from a database, or you can use UUID, which is pretty much most of the time this case. So now that we look at how can we describe the UI in a declarative way, as a way to describe our component, describing the UI and adding interactivity, now it is time to look at how can we manage this state, as a way to know how can we actually show relevant data and prevent some common gotchas when writing your React components. And that is, well, this is some principles I mentioned. Group related state together. Avoid any duplications because it is hard to keep in sync those states. Avoid redundant states. Ask yourself, can I get this data from its props, from its another state? And this is something very narrow specific to React, just to mention. And that's exactly what we're doing here. Learning what is the React way of doing things. That's all. And what is its trade-off also. So what this tool allow me to do and what it is trade-off. As well as now eliminate or avoid any deeply nested object in your states, because updating them is something that is quite annoying. So by looking at this and how you can organize your states, then we look at how can we now share an states across different components. Okay, now that we know how can we describe your UI and adding interactivity and describe the UI to react to inputs, and how can we organize our states, and this is the way of how they organize the state is following is the concepts of the normalization in database engineer from the database engineering as a way to eliminate redundance and eliminate redundant data and duplicated data. Now that we know that, okay, it is time to look at how can we now share that state across different components. So this is known as lifting state up, which is a very common thing that you're gonna do. For example, in your filtering, when you define is a search followed by the list of elements, that actually is a pattern in React. Okay, you're going to have a state in the pattern components, and then you're going to share that state through its props, followed by the event handler, and then render the elements or the state that you need to, right? So this is something that you're going to see a lot of the time, for example, in tabs, in product filtering. Again, all of these specific and very particularly components. And the idea here is that when we are describing our components, it is important to look in terms of what is, how can we design this component and what capability this component will have. Because with that, now we can finally look at what is the responsibility that this component will have. Is the information that this component will manage is by the state, we call them a uncontrolled component, or is this information will be handled by its props, we call that control component. And when you define your states, each piece of unique state, you will choose whose component or what components owns it. And this is known as the source of truth for all of those components that make use of that. Something that we're gonna see how can you, for example, abstract that state followed by the update state logic in context. But I don't want to go to that. But what I want to describe here is that particular concept. When you put this piece of states in your component, you are making this component as to act as the configuration, okay, for all of the other components that consume that state. So if you want to make your components much more manageable, in other words, if you want to have a more state update logic and organize all of your state update logic, first we'll look at how can we how can we look at how React now preserve and reset the state. Why is that? Because after all, any time, for example, you want to render the same component in the same position, React will preserve the state, because for React, the state is tied to the position of the render tree. And this is the way of how they manage that, the behavior by default. So if you put all of these components at the same level, so React will going to preserve the state if they are the same components. Okay. However, if you put different components in at the same position, React will reset the state. If you want, for example, reset the state of the same component at the same position, well, you have several alternatives. Or you render that in a different position of the tree, or you use a key as a way to notify, hey React, I want you to keep track of this component, even though they are the same, but I want you to, anytime we call them, or you re-render this, reset the state. So that's quite interesting. That's quite interesting. It is resetting the state at the position of the render tree. Okay. So depend of how you're passing that key is going to reset that at the position of the render tree. So because as I mentioned, we're talking about is lifting a state up, and how now by each piece of state you choose which component owns it. Okay. And when you now remember is how you can update your state logic, and the more inputs a state needs to react, or you needs to manage, the more cumbersome and large your code becomes. So as a way to now make the state update logic short and concise, we use reducers. One, something important here, keep the state update logic with reducer. Good. And the other, which is, we look at how can we do that with reducer. It's also part of the hooks from React, that I'm assuming that all of these are closure behind the scenes. It's a nice little bonus feature from JavaScript, that when you return that, when you return a function from another function, it get the lexical it let you access to the other lexical environments, even though the function was run, as a way to preserve that data. That's go beyond the scope of the word. That's the reason why in the docs they call that state is a memory. It's a components memory, or it's a components. It is. You can think of that as a components memory, and that is the reason behind the scenes. It's because they're using closure, or I'm assuming that. So. So to keep our state update logic sync, or to keep our state update logic maintainable, we use reducer. And this reducer is just a name that comes from the reduce method from the array, where you have a collection of elements and then you want to accumulate its value to get a single output. Okay. So the idea here is that even though that you pass several state updates or one, you just want is to actually get a new update state, the last update state. You accumulate all of the previous state update. So it's like you're telling to the waiter, hey, um, uh, I want I want a banana split. No, I want a beef stick. No, give me some Perrier water. You know, and then he said, okay, I'm gonna take your last order. All right, that makes sense. You know, you can think of this like that, and so with that, okay. Okay. So with that, uh, the whole point of this um, is that now, once we understand how can we share state between components, known as lifting a state up, and the reason of looking at that is because, hey, now this component will become the source of truth of all of these other components. So with this mindset here, and also we look at how now the state is tied to the position of the render tree. So when it comes to actually keep our state update logic maintainable, we use reducers, which is pretty interesting, okay, and how these things work. So this is a hooks that you can use in your custom, your React. First, you start by replacing all of the set states with dispatch, and then you're gonna pass inside of this function called an object called action that have the type of the actions, and all of these actions describe is a specific user input, okay, or a specific input, whether it's computer or human, but it's defined a specific input, okay, usually in a specific use state. So for example, like this. Mm-hmm. Exactly. Exactly. Each action describes a single user interaction. All right. Even if that leads to multiple change in the data. So with that, once you define is once you change the setter to dispatch, and then you pass the proper object called actions to the reducer function, where you take this is just a fancy name to say this is a function that receives a state and a actions to generate a new bit of a state based on a switch statement here, and then you're going to evaluate that. So that's quite interesting, quite compelling, because now that leads us to the next topic as a way to say, now how can we pass data to distinct components as an alternative of props, especially if you want to pass down data to, if you have hundreds of dozens, if you have dozens of hundreds of components, how you can pass down that data to those distant components. So instead of passing that per props, which is known as prop drilling, okay, the idea here is to say, no, let's going to avoid this because if any of these components removed from the DOM, some functionality actually make that to remove them from the DOM, for example, hide them or show them, then you break the entire chain. So to prevent this, we use context. We create a context with the create context function from React that it represents is which context from other components can read or provide. Then we use those components from the component that we need to using the use context, okay, as the consumer. And then we provide is the context followed by the value in there. So we look at how can we do this, how convenient it is to actually pass on to long distance components. And on that topic, we also saw how, on that topic, we also look at how tempting it is to overuse the context. So before using context, start with props first. If not, then extract the GSX elements into a component and pass it as children. So because one of the things that context behind the scenes does is that any components so React will re-render, because after all it's a React hooks. So React will re-render the components. So React will re-render all children that use the specific components starting from the provider that value change. So the provider actually is get called. It means it's going to evaluate all of its functions, and inside of that context you have an state, which is something common known as state lifting, as a way to say, hey, the source of truth will be the context, not this component, now will be is the context. So if you now change if you now have this alternative of who state owns the components, okay, it becomes quite hard to keep track, and not only that, to understand that which component actually trigger a rendering this. So this is one of the reasons when you now want to make your update logic consist, short, and make a single source of truth with your context, is quite useful to use is the state followed by the reducer, as well as some performance optimizations like use memo and use callback. Why is that? Because React, we're going to re-render all of the children component that make use of that context, starting from the providers that pass that value change. What happens is the provider, if that contains any state or functions, because after all, JavaScript is when React evaluate or when React re-render this, is just a component, is a JavaScript function. So JavaScript create a new branch execution context, and anything that you define in there is a new referencing memory, which means that even though that you have the same value of an object or a function, or that function is the same, it will have a different referencing memory. Therefore, they are different. Therefore, they're going to change. They're going to cause that the provider function updates, causing is to now all of this rippling effect to all of the other components. So that's something that you don't want. That's an undesired side effect from this. So how you can prevent that? Well, if you're going to make use of a state, which is something common, all right, you first define, for example, if when you combine is your reducer with your context, the most common way to look at that is, or the most common use case when you're going to use context is for theming, when you want to now make all of these components to adapt to its surroundings. Hey, change the state. The other is for authentication, which is a small piece of data that you want to actually share through your components that use that context. For example, the browser router actually use context. The React router use context, and for managing its states inside with reducers. That's when it becomes very compelling. Again, because now the source of truth, instead of actually, now the source of the state, now the source of truth for this state, instead of being on the component level, it'll be at the context level, which means that you centralize this state, okay, and any component that want to make use of that can consume that, all right? And you need to define is the provider as a way to make that data available to any child that have access to. But you need to also is use some of these optimizations techniques. As I mentioned, use memo and use callback. So use callback. Preserve is the functions it catch a function. Yeah, so use callback catch a function for that. Yep. Use callback. Catch is a function to avoid re-rendering it. And the other is use memo, that catch is a computations to avoid re-rendering it. So most of the time you're going to see this particularly techniques in the context, and when it comes to combine with reducer as a way to make your state update logic maintainable. First, you create a context for your state. You create a context for your dispatch to the update logic. You define is the function with your, you define is the provider function that inside of that you create is your states, okay, that you want to. And then right below that function provider, you're going to define is all of your reducers. And inside of the event, inside of the provider functions, you're going now to this. You're going to return is the state provider, which contains the value, okay, followed by the dispatch provider that will contain is the state update logic, and you want to return is all of the children. So you want to also receive the prop as children and render all of the children that this application has. So with that, okay, and I think that was quite interesting as a way to describe how can we actually make this happen, okay? That's quite wild. That's quite wild. Totally. So now we look at the escape hatches as a way to being able to describe is this, is that some of your components, your JavaScript functions, needs to sometimes interact with external systems. So you want us to focus on inputs by using the browser API. You want us to play or pause a video implemented without React. Okay, or connect and listen to message from a remote service. These are very specific use cases, but the thing here is that we're gonna see is what are the concepts that is behind the scenes here. All right. I mean, that was quite interesting, that description. It took me like a half an hour to actually describe all of this as a way to make sense of how we're gonna do these things. Okay, and then you got some of your component here, right? So in this chapter, you will learn the escape hatches that let you step outside React and connect to external system. So most of your application logic and data flow should not rely on this feature. As one of the concepts of single source of truth is more important than ever here. So again, we're gonna look at how to remember information without re-rendering using the useRef, which is this nice little components pocket, okay? That is going to be triggered is on an event handler. That's to me quite interesting. For example, like this, okay? You can remember things without trigger re-renderings. For example, without triggering state updates. That's interesting. So for example, the use cases for this is timeout, and DOM elements, and other objects that don't impact the components exactly, and other elements that don't impact the components rendering output. How to add a reference to your component, how to update a ref value, how ref values are different from state, how to use ref safely. You can access the current value of other ref through the ref.current property. This value is intentionally mutable, meaning you can both read and write. It is like a secret pocket for your component that React doesn't track. This is what makes it an escape hatch from React one-way data flow. More on that below. Here's a button that will increment its ref. But I just want us to look at this, to understand all of this concept here as a way to now make sense of this. And then when we need to dive deep into this, we make sense of that. So on the escape hatches, we're going to see how sometimes we need our React components to interact with external system. Okay, whether it is to focus the input using the browser API, pause or play a video without a player implemented without React, okay? Whether it is from the video or from any other wrapper as well. So how can we actually interact with that using ref, or connect and listen? This last section is something important. Is here. It's like play and pause a video player implemented without React. Most of the time we're going to interact not only with native solutions, okay, browser int or node built-in, but also with other implementations, with other systems, okay? Not only here with the play and pause video implemented without React, but some other, for example, analytics and that kind of thing. Or connect and listen to message from a remote server. So first, we're gonna look at how to remember information without re-rendering using the useRef. So this is like a pocket, like a secret pocket that React doesn't track, okay? So it is like a secret pocket of your component that React doesn't track, which means that it doesn't trigger a re-rendering, okay? Manipulate the DOM with ref. In this case is how to access DOM elements managed by React. How to access DOM element with React. something that I'm quite familiar with. Example, scrolling to an element. Current scroll into view. Okay. Scroll into view. Scroll into view. Scroll into view, but that doesn't work. Oh, but that doesn't work. Or at least doesn't work is hitting. Okay. Up. Anyway. So way to navigate to the. Okay. How to manage a list of ref using a ref callback. Accessing another component's DOM. Cannot be given ref. Attempt to access this ref will fail. Oh, forward ref. Forward ref as a way to make access to my input. But you should use that sparingly. when React attaches the ref during render, during commit. During commit, React apply change to the DOM. '21. List scoring element, last child, scroll into view. Exactly, but this is, you want to cover these specific use cases. Okay, best practice for DOM, manipulating with ref. Ref are an escape hatchet, and you should only use them when you have to step outside React. Common example of this include managing focus, scroll position, or calling browser API when you need to communicate with external sources that React does not expose. If you stick to non-destructive actions like focus and scrolling, you shouldn't encounter any problem. However, if you try to modify the DOM manually, you can risk conflicting with the change React is making. To illustrate the problem, this example includes a welcome message and two buttons. The first button toggles, it is present using conditional rendering and a state, and you will usually do in React. The second button uses remove DOM API to forcefully remove it from the DOM outside of the React control. So for example, here we're looking at now escape hatches, things that are going to happen outside of React. So show set and ref. Okay, so on click set show, toggle this set. We're gonna set show. So far so good. It's gonna actually show that. But here when you say this, you are going to add is a new element here. Okay, it's actually adding a new element here. When you toggle to false, toggle with set. Exactly. Toggle with set. When you do this, which is, hey, now I get this thing that I can remember without trigger a rendering, okay, which is actually getting a ref here, remove from the DOM, you remove that and you won't never apply that again. You know, it's like, hey, that doesn't exist. Node to remove child, the node to be removed is not a child of this node, because you actually is, you mess up with, you mess up is with the way how now React is constructing that. So after you have manually removed the DOM elements, trying to use a state to show it again will lead to a crash. This is because you have changed the DOM, and React doesn't know how to continue managing it correctly. Avoid changing DOM nodes managed by React. For example here, hey, this is actually managed by React because it's using the curly brackets, it's using an state. Hey, no, avoid that kind of thing. Modifying, adding children to or removing children from elements that are managed by React can lead to inconsistent visual results or crash like above. However, this doesn't mean that you can do it at all. It requires cautions. You can safely modify part of the DOM that React has no to update. For example, in some div, it's always empty in the JSX. React won't have a reason to touch its children list. Therefore, it's safe to manually add or remove elements there. For example, in some div, if some div is always empty in JSX, React won't have a reason to touch its children yet. Mm-hmm. So play and pause the video. Focus the search field. Scrolling an image carousel here. Okay. Focus the search field with separate components. Oh, okay. You're actually rendering is this in different elements. Therefore, it's gonna reset the state. Looking for something. Search button, search input. Focus the search field with separate components. Make it clickable in search button. Okay. But first thing first, as a way to recap this, which is I think this should be quite an interesting thing here, as a way to organize, as a way to structure our knowledge here. With escape hatches, anytime you want to interact with, for example, browser APIs or some other implementations or some other libraries implementations, systems outside of React, for example, player implementing in other place, carousels and that kind of things, you're likely to connect to a server. Okay, to connect and listen to a server, you're most likely to use these escape hatches. Okay, which is how how to remember information without re-rendering. Okay, how to access DOM element managed by React. Hear this: how to remember information without rendering using the useRef, which is this secret pocket that React doesn't track. Okay, how to access DOM element managed by React. Okay, how to synchronize components with external systems. Yeah, how to synchronize component with external systems using effect, how to remove unnecessary effects from your components. Okay, how an effect's lifecycle is different from a component, how to prevent some values from retriggering effect, how to make your effect rerun less often, and how to share logic between components. So here is now actually organizing this fashion. First, how you can now use ref as a way to now control or synchronize with other external systems, as a way to control, okay, and how to remember information without rendering, and how to access DOM elements managed by React. And the other is that how to synchronize here, okay, how to synchronize, how to synchronize, so for example, how to connect and listen to a remote server's message, how to connect and listen to message from a remote server. So for example here, and how you share logic between components. So that's interesting because now what I'm gonna do is to actually make a quick, okay, take a look at this. Okay, okay. Let's get into this. Follow me into battle. Okay. Mm-hmm. Let's get into this. How to remember and then how to access to the element managed by React. Okay. So when you want a components to remember some information, but you don't want that information to trigger new renders, you can use a ref. So how to add a ref to your components, how to update a ref value, and how to ref a different, how ref are different from a state, and how to use say ref safely. All of this is how to add, update, ref from a state, and how you use ref safely. Okay. So adding a ref to your component. You can add a ref to your component by importing the useRef hook from React. Import useRef like this. This is how you can add this. So far, so good. So useRef returns an object like this. Okay. So we use ref. You now return this an object like this. Hey, I got a reference here. This is my reference line. With the current. Okay. You can access the current value of that ref through the ref.current property. This value is intentionally mutable. Okay, this value is intentionally mutable, meaning you can both read and write, and it is like a secret. And it's interesting because when in the React ecosystem they describe about this is mutable, it means that hey, you can read and write on that. Most of the time you don't want to write. You prefer to generate a new state out of this. But in any case, meaning that you can both read and write to it. It is like a secret pocket of your component that React doesn't track. Okay. So hey, it's like I have this secret pocket that React doesn't track with the current ref. This is what makes it an escape hatch, because React is not keep tracking of that. From React one-way data flow. Oh, so React is not keep tracking of that state or that data, so it is outside of this. Is now. More on that below. Here is a button that will increment the ref.current on every click. Exactly. This is how you can add, and on any click, on any event handler, and any input. On any event or on any input, in this case user input, it actually is store that information. Hey, I want you to store this. Okay, without trigger a re-rendering. The ref points to a number, but like state, you could point to anything. A string, but it's point use ref. Okay, it is pointing to that. A string, an object, or even a function. Unlike state, ref is applying JavaScript object with a current property that you can read or modify. So this is some pretty much like when you're using now is the dispatch that you have to send is a special type of object. The content is a type. Okay, that's part of the convenience. It's not necessary. It's a convention. All right. Note that the component doesn't re-render with every increment. Exactly. So note that the component doesn't re-render with every increment. Exactly. Like states, ref are retained by React between renders. However, setting a state re-renders a component. Changing a ref does not. So note that the component doesn't re-render with every increment. Exactly. So when you're now because it's not trigger a re-rendering, it's not trigger this rendering mechanism. Render and commit phase. So okay, so useRef, after all, is not triggering is a rendering. However, it's a special pocket that allows you to remember things between re-renders, between calls. Okay. So between calls, it'll allow you to remember things. Okay, example, building a stopwatch. You can combine ref and state in a single component. For example, like make a stopwatch that the user can start or stop by pressing a button. In order to display how much time has passed since the user pressed start, you will need to keep track of where the start button was pressed and what the current time is it. Oh, when you stopwatch, okay, you're gonna get exactly start time, set time, and now and set. When you use press start, you will use set interval in order to update the time every 10 milliseconds. So for example, like this. So it's going to implement now a timer here. So when we click here, we're setting the state to now. And here, start counting. Okay. And all right. Okay. And then I want to update is exactly. And then inside of the event handlers, I want to use a timer, which is using the callback queue behind the scenes as a way to update this, or as a way to say, hey, any 10 milliseconds I want you to run this. Makes sense. Here you have his second pass. So if the start time is different from null and now is different from null, which is now you can keep tracking of this. In other words, if they're already started, second pass will be the difference between them. And that's what you're going to show to that. Okay? So anytime you are now re-render this and re-render this and re-render this and re-render this. So when we click here, it's gonna call this the handler star set the state initially, which is a start counting, and then call inside of the event handler this timer. We also like is to avoid or to clear that interval as a way to say, hey, I want you to now stop this. I want you to stop this calling here. Clear the interval. Okay. So it's now going to set that, and that's it, right? Pretty much. It's like a timer. So you should be able to do that. So when you press that again, okay, it'll now is to reset that. Exactly. It'll now to reset that. And reset it and then reset that. The time that is showing here is the time pass, which is second pass. Like so. Like so. All right. So it is second pass to fix, which is a number and that kind of thing. So when you stop the button is pressed, you need to cancel the existing interval so that it is stop updating the now state variable, and you can do this by calling the clear interval. But you need to give the ID, internal ID that has previously returned by set interval. So if we define as another button here, when the stop button is pressed, you need to cancel the existing interval here. So you define as another this, but you need to cancel is the another interval here? Because you define this reference inside of the event handler, now you can hold that reference and clear that up. So for example, I can even implement that here by saying something like this. By saying something like this. And if this on click, which is stop, you're gonna say handle stop. Of course it doesn't exist because I'm going to do this. And here I'm gonna say, hey, let's go to define a handle stop, which is an arrow function. I prefer to do this. No, I don't want you to receive anything here. Okay, which is this, right? Handle stop. And because I need to have a reference as a way to clear the interval here, well, I can use the const timer ref. Use ref, where now initially is null. Call that reference this special or this this magic pocket or special pocket. Okay. This escape hatch, this magic component here, start use ref, but it say secret pocket, exactly. So now that you have this secret pocket here as a way to say, hey, when you are here, okay, when you are here, I want to hold is the reference of this interval. You know, I want to hold the reference of this interval, meaning I would like to say now timer dot ref dot current, it'll be equal to this. Okay, so now that I hold that reference, because after all the use ref is a plain JavaScript, I have this secret pocket using this custom hook use ref as a way to say, all right, now on handle stop, I want you to now set the state, set start time to 0, set now to 0, and after that clear the interval, which is called the clear interval here, and say timer ref dot current, and that's all. You pass here handle stop. So what it's going to do is to set that 0, 0 and clear the reference for that. Holy moly. That's quite interesting. So look at what we're doing here, because now we are remembering things that happening outside the React world, unlike states, okay? So if you need to, for example, control, which is exactly what we're doing here. If you need, for example, some components need to control or sync and sync with external system. For example, here, the timers. The DOM. And a good example here is the DOM and the timers. other React or any other JavaScript libraries. So useRef is a way of how you can remember things outside of React. Escape hatches. Okay, for example, as a way to now clear the interval in a time watcher or in a stopwatch. You start and then you stop. So you now have the reference not only for elements, HTML elements, but also for external systems here. So you keep track of that, you remember that, and then you do what you gotta do. Oh my F God, holy moly. Interval ref. You have now the clear interval ref.current interval ref.current. But this is if you want to exactly. Oh, of course. Okay, because if you do this, you're creating a new. Oh, okay. You're creating a new instance of that, and you want to actually release that. Clear interval here of the time current. And then you stop that. Hey, what the hell? Exactly, because it's like, okay, that's fine. No, that's fine. That's fine. That's fine. So we start it and we stop it. We start it and we stop it. But the thing is that, that's right, you stop it, but you initially need to also stop that reference if you have one. That's interesting. That's very, very interesting. Yeah, you start, you stop, then you start, and then you stop. Exactly. But anytime you, this again, because this is the behavior that you want to start. You know, this is the behavior that you want over and over and over. Oh, but in my case, it's like start. Oh, because I said that. Okay. Yeah. Okay. I said that to the sec exactly. If you want to now stop that, you say, hey, second pass. Oh, but you need to fix that. Clear interval. Again, depending on what is the behavior that you want. Exactly. This is the behavior that you want. Since the interval ID is not used for rendering, you can keep it in a ref. So when a piece of information is used for rendering, keep it in a state. When a piece of information is only needed by event handlers and changing it doesn't require re-rendering, use ref using a ref may be a more efficient. But the deal is that when you have a piece of information is only needed by event handlers, and changing it doesn't require re-rendering. That's what it is. So difference between ref and state. Perhaps you're thinking ref seems less strict than state. You can mutate it instead of always having to use a state setting function, for instance. But in most cases, you will want to use a state. Exactly. As a way to, if this information needs to re-render state. Ref as an escape hatches you won't need often. Here's how state and refs compare. Return this. Use ref initial value returns the current and this. Use a state like this. Doesn't trigger re-render when you change it. Triggers re-render when you change it. Mutable is immutable. You shouldn't read or write the current value during rendering. It can only state at any time. However, each render has its own snapshot of steps. Each render has its own snapshot of state, which does not change. So here is a button that's implemented with state. Exactly. It's actually anytime here is setting that and is re-render. Because the value is displayed, this is what you can do. But does not update it is states. Exactly. But of course you have that. How does useRef works inside? Although both useState and useRef are provided by React, in principle useRef could be implemented on top of useState. You can imagine the inside of React useRef is implemented like this, where you have the current initial value. During the first render, useRef return current initial value. This object is stored by React, so during the next render, the same object will be returned. Note how the state setter is unused in this example. It is unnecessary because useRef always needs to return the same object. React provides a built-in version of useRef because it is common enough in practice. But you can think of it as regular state variable without a setter. If you're familiar with object-oriented programming, ref might remind you to instance field. Instance field, but instead of this something, you write something that current. When to use ref? Storing timeouts ID, storing and manipulated DOM elements, which we'll cover later on the next page, storing the other objects that are necessary to calculate GSX. Best practice for ref. Following this principle will make your components more predictable. Treat ref as an escape hatch. Ref are useful when you work with external systems or browser APIs, like this. When you want to work with external systems or browser API, use this secret pocket as a way to hold something. Perhaps storing time ID and then clear that out interval, or storing and manipulating DOM elements. Storing all the objects that are necessary to calculate the GSX. If your component needs to store some value but it doesn't impact the rendering logic, choose ref. Exactly. Hey, do I need to have these informations that is going to be passed on to that, but I don't need to render that? Use ref. A good example of this is components, okay? Null component. Components that doesn't return anything. Best practice for ref. Following these principles will make your components more predictable. Treat ref as an escape hatch. Ref are useful when you work with external system or browser API if much of your application logic and data flows rely on ref. You might rethink your approach. Don't read or write ref current during rendering. If some information is needed during rendering, use state in that. Limitation of React state don't apply to ref. For example, state act like snapshots for every rendering. Okay, and especially when we know what happened out of the state during rendering, is that it acts as a snapshot of every rendering. Mm-hmm. It's like, hey, during this rendering, this is the snapshot. The next time I call this function, is this new snapshot, and so on and so forth. This is because the ref itself is a regular JavaScript object, so it behaves like one. Ref and the DOM. You can point a ref to any value. However, the most common use case for a ref is to access DOM and to handle timeout like this. For element, this is handy if you want to focus an input programmatically. When you pass a ref to a ref attribute in the GSX like, React will put the corresponding DOM element into my ref current. Once the element is removed from the DOM, React will update the my ref.current to be null. But again, because after all, we're looking at these escape hatches as a way to when a component needs to have control and synchronize with other external systems, whether it's browser APIs, play or resume is a video implemented without React video player, okay, or to connect to a certain or to connect to connect or connect and listen to message from a remote server. Now it makes a lot of sense to use ref, this secret pocket, this way of to remember things without re-rendering, without trigger re-rendering. Okay, okay. So fix a broken chat here, fix a broken chat input. Type a message and click send. You will notice that there is a 3-second delay before you send alert. During this delay, you can send undo button, click on the undo, but it's supposed to stop send. It does this by calling clear timeout for the time it saves during the handle send. However, even after undo is clicked, the send message still appears. No. Send. Find why this doesn't work. Oh, because it's sending that. Okay. So you now want to hold this as reference, useful full time IDs, okay, for these specific use cases. So here you're setting set is sending false and handle undo and clear the timeout ID. But this must be is a reference that you're going to pass, that you're going to store here and then pass down here when you need it. So it's use ref as a way to store this outside of React. Okay. So initially is null when we handle send here. Okay, when we handle send here, set is set to true, send that. Now here we must have access to the current object, very specific to this, where now it's going to send that. But for some reason, if we do that, I don't want you to trigger that. Alert send is sending false. So after 3 seconds, no, I don't. I just want to stop that. I just want you to stop that. Disable is handle. On handle send is sending. On click handle undo. because we need to pass is the current value this. Exactly. So now what you're doing behind the scene is to say, hey, I want you to set timeout here. I want to run this callback here anytime that happen. But if you interrupt me, it's like, no, 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 I don't want you, I don't want you. Hey, here's a D. Clear that. All right. Come on. Mm-hmm. So let timeout D don't survive between render, because every renders run your component and initialize its value. That's what happened here. So let here doesn't survive because it will get triggered on any because it will be re-rendered. Mm-hmm. Don't survive between re-renders because every re-render runs a component and initializes its values. It creates a new branch execution context. The other is this: fix a component failing to re-render. Yeah, fix a component failing to re-render. This button is supposed to toggle between showing off and off. However, it is always show off. What is wrong with this code? Oh, because this is a rendering, because useRef is a secret pocket that does not cause a re-render. I mean, it's a secret pocket that doesn't cause a re-render, or that doesn't trigger a re-render. So if we use state for that, we're going to fix that issue here. Because exactly it's setting the state and that kind of thing. So we need to actually here say, hey, is one ref, is on ref, set is on ref. Okay, so set is on ref, and then let me actually toggle this. Is on ref. Oh, because of course, you know, here, even though that we're triggering a re-rendering, but it's not rendering that element because it doesn't have any value like that. It's here that actually do this. You know? So anytime you're doing here, you actually trigger a re-rendering. So this is a sign that this information should be in a ref. And then really how they talk about this state and an information or this data. Hey, this data, this is an indicator that this data should be on a state. To be on a state for that. Because the current value of a ref is calculated, is to calculate a rendering output here. Here this is a sign of this. Again, use state and use ref are a way of how you can remember things. But use state now triggers a re-rendering, therefore you can see the visual change, whereas the use ref doesn't trigger a re-rendering, and it is, yeah, but use ref is a secret pocket where you can remember things, where you can remember things between re-renders without, exactly, between re-renders without, it's a secret pocket that you can remember things between re-render, between renderings, but it doesn't trigger an UI, or it doesn't trigger a UI element. It doesn't trigger a So useRef survived to between renders, but it doesn't pass through the rendering mechanism, which is apply the DOM updates to that. Though that the component doesn't re-render with every increment. So this information is used for re-rendering, so you will keep in a state. Again, this is to cover a specific business use case for that. Uh, so, yeah. So best practice of this is that do not read this on that. The TLDR is that useref is a special pocket. Is a yeah. It's a special pocket that remember things between re-render, but it doesn't show things on the UI. When you want to show information on the UI, all right, is this. And again, when to use ref, most likely is for DOM element, storing IDs. But you know, it's very specific here. So storing timeouts ID, storing a manipulated DOM element, which we cover on the next page, storing other objects that are necessary to calculate GSX. So when to use ref? With timeouts ID, storing and manipulated DOM elements, usually, for example, inputs or videos, that kind of thing. Okay, so storing timeout, exactly. For storing timeouts IDs, for storing timeouts ID, for storing and controlling DOM elements, okay, which we'll cover in the next page, and storing objects that aren't necessary to calculate the GSX. So when I look at now the React intermediate, like this. So when I look at this, okay, use ref, use reducer, use callback, use memo, use layout ID, use ref. For example, here. Okay. Wait, what? No. But use ref. In this example here. Now I think I understand what it's doing here. So here you are defining is this special pocket, okay, to remember things between re-renders, but you don't want to show the data. So let's continue rendering true, and here you are now is invocating this 3. Okay, makes sense a lot here. 3, yes. All right. A new thread perspective camera here. Render is new thread WebLG rendering. Okay. Render set the size as a way to indicate the viewport, window inner heights, and that kind of thing. So your access to that, and you are now using an effect as a way to synchronize or desynchronize to external system. In this case, like the 3GS. Geometry, material cube, directional light, camera, okay, position, continue rendering, request anime frame for this, like, get me this, get me this, get me this. It's like run this function. Oh, okay. request animate here. That's interesting. So you're going to run this function in Windows, request animation frame. Notify the browser. Method tell the browser you wish to perform an animation. It requests the browsers to call a user supply callback function before the next repaint. Hey, I want you to know this is instance method from the window object. Okay. Mm-hmm. Mm-hmm. Performance.now. Mm-hmm. So window request animation frame method. Window cancel animation frame. Request animation frame. We should always. This is interesting. Request animation frame. It's like, hey, I want you to now paint this and this and this and this, which is something that must come from the window. So function animate, and they say continue rendering true. Request animation frame and animate this, which means it's calling this function in a recursive way. Okay, cool, cool. Cube rotation here, render here, and here not only call that function, okay, but also if continue rendering is true, call that, calls that. Now rotate the cube a little bit in G and in X and G, and call these render functions to render is the scene and the camera. So for example, if we look at the use ref here, and then we say, hey, I want you to now position the camera here. Okay. Okay, the position of the camera here. Holy moly. Add light. Mhm. Mhm. But that's interesting. Now this animate this is calling animate, and what you want to do here is to desynchronize here. Hey, you just want to clean up here. So here by now having is this the render.current. Okay. So when you render this, okay, exactly the position of the camera. Mm-hmm. So what you're doing here is that because now you hold a reference to this, okay. Now you are going to you are going to manipulate is this exactly. So this is now where you can have control of or synchronize not only with because useref is a pocket, a secret pocket that allow you is to hold a reference, whether it is on the ID or on an object or even a function. But the idea here is that this is a special place where you can store things between renderings that is not going to reflect on the done, so it's not going to paint that. So the use case of this is clearing the timeout, uh, clearing the timeout by using them as a timeout ID. Mhm. Manipulating DOM elements or any other information that doesn't depend on GS rendering. Mm-hmm. Exactly. Storing other objects that are necessary to calculate GSX. Interesting. That's a very interesting here. So launch the spaceship launch, boil the soup boil, sing a lullaby. In this example, all click handlers are debounced. Debounced versus troller. Why patching global is harmful. My struggle with Remix. In Ukraine. Learn how to mock REST and GraphQL API with mock service work. total mess behind GitHub Accelerator, the dark side of open source. Mm. A total mess behind GitHub Accelerator. Mm. Epic Web. Ship mother full stack web app. Professional web form. Data modeling. Web authentication. Full stack testing. Interview with experts. Mm. 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 Oh, because it's can see that. Okay. Mm. Okay, 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 okay. Okay. Cool, 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 cool. Great for you. Great for you. Exactly. This explanation here. Exactly. Implementing through. The throw. And the other is the bound. And then. Mm-hmm. Exactly. Throw. Like let's going to wait for this amount of seconds. Throw is a sprint that throws ball. Mm-hmm. It's like throwing a ball. After a ball flies up, it needs to some time to shrink back. It's an overloaded waiter. Oh, okay. The bounce is an overloaded waiter. If you keep asking him, your request will be ignored until you stop and give some time to think about your last request. Inquire. The bounce is an overload waiter. The bounce is an overload waiter. And throw is a sprint that you throw balls. It's a sprint that throw balls. It's a sprint that throw balls. It needs some time to shrink back. An overloaded waiter. Good, good. So this example of all button click handles are debound. To see what this means, press one button and notice how the message appears a second later. The bounce button, the bounce button, the bounce button. Okay. So if you keep clicking the same button fast many times, the message won't appear until a second after you stop clicking. The bounce lets you delay some action until the user stops doing things. This example works, but not quite as intended. The buttons are not independent. To see the buttons are not independent. Exactly, because it is exposing is that. The bounce let you delay some actions until the user stops doing things. This example works, but not quite as intended. The buttons are not implemented. To see the problems are not independent. To see the problem, click one of the buttons and then immediately click another button. Oh, okay, it's not throwing that as supposed. You expect after the delay you will see both bottom message, but the last bottom message show up. The first bottom message get lost because you don't hold a reference for that. Exactly. So you only see this, but they all get lost. So one way to do this is to say this timeout here. Okay. I want you to now make a reference for that as a way to hold this information between re-renders without trigger a re-render. Okay. In it's going to import the use ref from React. Okay, as a way to say, yep, import use ref. Okay, and now here you actually going to have a reference. Anytime you clear up this, you want to clear out the current reference. Okay, and then hold a reference for the current one. So you keep track of all of this ID. So when you say now clear here, it say, hey, let me clear up the current timeout ID if I have one. Okay, so by default I don't have one, which is null. All right. By default I don't have one. Okay, but I'm going to perform this on clip event that I'm receiving from the parent after 1 millisecond, and then clear that up, right? You know, now it actually is debouncing. It's actually now showing us this function as expected. So now I'm keep tracking is the reference of this, and then clear the interval up. Read the latest state. Oh, read the latest state. Oh, read the latest state. Usually this behavior is what you want in an app. However, there may be occasional cases when you want some asynchronous code to read the latest version of some state. You can think of a way to make the alert show the current input rather than what is what at the time of the click. State works like a snapshot, so you can read the latest state from an async operation. So state works like snapshot, so you can read the latest state from a so you can read the latest state from an async operation like timeout. However, you can keep the latest input text in a ref and it's mutable. So state work like a snapshot, so you can so you can work, so you can read the latest state from an async operations like timeout. Okay, I think that'll be all for this video. Take care. Bye bye.